All right. Great morning, AP statisticians. This is a question from Grant. Thank you for this question, Grant. This is about question number 17 in the Chapter 11 homework, page 695 in your textbook. It has to do with Gregor Mendel and the P's. Okay, so we have this, basically Mendel predicted a ratio of 3 smooth P's for every 1 P. And then we have our observed counts where he observed 423 smooth P's and 133 wrinkled P's. We're carrying out a test to see if Mendel's predicted ratio is correct. Okay, so the reason why I love this question is because it actually is a great connection between a chi-square procedure and a z procedure. Okay, so I'm going to show you both, because this actually could be done in 2 different ways, and you're going to get the same exact response, same exact decision. Okay, so starting with the chi-square goodness of fit test, that's what we got going here. So we have the observed counts, 423, the wrinkled counts, 133. That's a total of 556 P's that he observed. Using his expected ratios of 3 to 1, that would be 75%, 25%. We can come up with the expected counts. If his hypothesis is true, he would expect to have 417 smooth P's and 139 wrinkled P's. So when we do a chi-square goodness of fit test, we're testing how well this distribution fits a known or predicted distribution. So the null hypothesis is we'll just assume Mr. Gregor Mendel was right. We'll assume that the proportion of smooth P's is 0.75 and the proportion of wrinkled P's is 0.25. You could write that out in words either way. You could say smooth and wrinkled P's occur with a ratio of 3 to 1. That's the 75%, 25% ratio. Versus the alternative that smooth and wrinkled P's don't occur with ratio of 3 to 1. So this is a chi-square goodness of fit test. I skipped over the assumptions. They're all satisfied. You got to assume it's a random sample, 10% condition. Both expected counts are at least 5, so our sample size is sufficiently large. If we calculate the chi-square statistic, here's your work. 423 minus 417 squared over 417 plus 133 minus 139 squared over 139 gives us a chi-square statistic of 0.3453. Our degrees of freedom is 1. Okay, 2 categories, n minus 1, we have 1 degree of freedom. Therefore, our p-value is 0.5568. We have a large p-value. We fail to reject. We don't want to say that Gregor Mendel was right, which he was, but we don't have evidence to reject him. So we fail to reject Mendel's claim. All right, now here we get to the fun part. We said that this could also be done as a 1 proportion z-test. So if we did it as a 1 proportion z-test, we just talk about, we define the proportion of smooth P's to be 0.75. That's going to be our null hypothesis. Versus the alternative, we'll do a 2-sided alternative. The proportion of smooth P's is not equal to 0.75. We calculate the z-score, 423 over 566. That's our p hat value, minus 0.75. That's our hypothesized parameter, over root PQ over n. Root 0.75 times 0.25 over 556 gives us a z-score of 0.5876. And then when we calculate the p-value, 2 times that probability, 2 times the probability of getting a z-score above 0.5876, gives us a p-value of 0.5568. We fail to reject, and we don't have evidence that the proportions are different than 3 to 1. Okay? Now, here's the cool part. Did you notice that the p-value here is the same p-value here? Same exact p-value to the nearest decimal. All right? These 2 procedures, the chi-square procedure for goodness of fit and a 1 proportion z-test that's 2-sided, are mathematically equivalent. Okay? They will lead to the same exact p-value, which then would lead to the same exact conclusion, because they are equivalent. A chi-square goodness of fit is exactly the same as doing a 1 proportion z-test, 2-sided 1 proportion z-test. Now another cool thing is the z-score we got here and the chi-square statistic that we got here are also related. If you take this z-score, this 0.5876, 0.5876, and you square it, 0.5876 squared, guess what? 0.5876 squared is 0.3453. Okay? So there's a little hint why it's called the chi-square statistic, because for 1 degree of freedom, this only works for 1 degree of freedom. If there's 1 degree of freedom in your chi-square procedure, the z-score from a 1 proportion z-test, two-sided, would be that squared would be the chi-square statistic. Okay. Thanks, Grant, for that question, and keep up the good work.